Dr. B here, and let's talk about Le Chatelier's principle, also known as Le Chat. Henri Le Chatelier determined some time ago that if you adjust pressure or temperature or reactant concentrations or product concentrations, you can shift a reaction in any direction you want. Here's a reaction of A plus B to make C that's endothermic. If we add reactant, it will definitely shift to the right. And the analogy that I always use is that it's like stoking the fire. You're adding more reactant. If you add product, the opposite should happen. And that's because you're quenching the fire. It's like adding water to a combustion reaction. How accurate are these analogies? Oh, perhaps not very, but they definitely work. If we heat it, in this case, it will help because the reaction's endothermic. It needs heat. If we pressurize it, the reaction will always shift towards the direction of the fewer number of moles. And that works for this one. It'll shift it to the right because we have 1 plus 3, 4 moles on the left turning into only 1 mole on the right. The product has fewer moles. Let's do some examples. Here's a reaction that is oxidizing. It's endothermic. Let's apply these rules. We add some reactant. It'll shift to the right. We add some product, it'll shift to the left. We add some more reactant, shift to the right. We remove product, thinking of it as creating a gaping, we're removing starting material, I'm sorry. So think of that as creating a hole in the starting material side, it'll shift to the left. Remove product, there's a hole on the product side, needs to be filled in, it'll shift to the right. Remove oxygen, hole on the reactant side, shift to the left. Increase the pressure, 3 turns to 2. I like it. It'll shift to the right. Increase the temperature. It needs heat since it's endothermic. Yep, shift to the right. Decrease the pressure. Well, we already said that increasing the pressure is to the right, so clearly this will shift it to the left. This is Le Chatelier's principle.